Hello everybody, welcome to the IT Skills channel. In today's video, we're going to take a look at NLP, and this is a continuation for our AI-102 course. And this is pretty much about learning language detection, key phrase extraction, sentiment analysis, name entity recognition. And so this is very important for the certification, and we need to know it. So without further ado, I'm going to hand over to our presenter for today. And our presenter for today.
Welcome to IT Skills. I'm your instructor Ali. Welcome to our journey into the world of natural language processing, or NLP for short. Think of NLP as a bridge that helps computers understand and interpret human language, much like how you might translate between two people who speak different languages. We'll start by exploring what NLP is, its real-world applications, and why it's so crucial in today's technology-driven world. Think of analyzing a text like being a detective. You're on the lookout for clues, themes, patterns, and character motives that reveal the story's bigger picture. Now let's explore translating text, which is akin to being a bridge builder. You connect two languages, ensuring ideas flow seamlessly from one culture to another. When analyzing a text, it's essential to dive deep into its components, much like dissecting a complex recipe to understand each ingredient. Consider the author's purpose and audience, akin to understanding who you're cooking for. This insight shapes how you interpret the message. Moving forward, let's explore the language used, observing word choices as if they were spices that alter the flavor of your dish. Let's explore the core elements of language service key phrases. Think of natural language processing, or NLP, as a versatile tool that can dissect text into its essential parts. These features include language detection, which identifies the language used in a piece of text, and key phrase extraction, pinpointing significant words or phrases for deeper understanding. Imagine sentiment analysis as reading between the lines to gauge emotions conveyed in the text. Named entity recognition is like tagging names, places, and dates. Consider it a way of highlighting Manhattan or New York. And when we link these entities, think of connecting the news with New York, enriching our understanding of context. These NLP capabilities can serve as standalone resources or integrate into broader cognitive services. Entities like Manhattan, tagged with a positive sentiment, exemplify how text data is not just recognized but also evaluated for emotional tone. Language detection is like having a smart translator that figures out what language a piece of text is written in, which can be very helpful before diving deeper into the analysis. Imagine it as a detective identifying clues from different languages to set up further investigations. Topic: Documents. In our example, each document has an ID and contains text in various languages like English or French, along with associated confidence scores that indicate how sure the detection is. Topic: Model version. The system uses models such as April 1, 2020 to accurately identify these languages, ensuring reliable results. Additionally, there's a feature where you can hint at the country to improve accuracy, like using US for American English. Let's explore key phrase extraction. Think of it as highlighting the main talking points in large text. It works best on documents up to 5,120 characters. For instance, document 1 identifies change and word, while document 2 pinpoints miles, single step, and journey. This technique helps distill essential ideas from extensive content. Think of sentiment analysis as a mood detector for text. It assigns an overall feeling to the document and breaks it down by individual sentences. If all sentences are neutral, the document is deemed neutral. If there's any positivity mixed with neutrality, it's tagged positive. Conversely, negativity or both sentiments together result in negative or mixed feelings respectively. For example, in our document Smile. Life is good, sentiment analysis labels this as a positive text because of high confidence in its uplifting sentences. Named entity recognition, or NER for short, is like finding the names of people and places in a story. It tags Joe as a person, London as a location, and Saturday as a date and time. This process helps computers understand what's important in text by categorizing these entities into groups such as person, location, date, time, among others. Entity linking is a crucial process that helps clarify ambiguous entities sharing the same name, like Venus, which can refer to either a planet or a goddess. By leveraging context within text, this technique assigns specific Wikipedia articles to each mention of an entity. For instance, in the sentence, "I saw Venus shining in the sky," entity linking would identify Venus as the planet rather than the goddess. This disambiguation relies on contextual cues and utilizes Wikipedia as a knowledge base for accurate article links. Let's start by dissecting text analysis, which is like having a magnifying glass for language. Imagine we're sleuths, identifying the language and extracting entities as if uncovering hidden characters in a story. As we dig deeper, evaluating sentiment becomes our way of sensing the mood of the narrative. Now let's explore key phrases. Think of them as signposts highlighting important information. Finally, linking entities allows us to connect dots across various data points, creating a cohesive understanding of our text landscape. Think of translating text like swapping out ingredients in a recipe to make it taste just as good. Just like adjusting spices, each word needs careful attention to keep the original flavor. Topic: Translation accuracy. Ensuring precision in translation is crucial because even small changes can alter the overall meaning. Let's explore how context plays a key role. Imagine reading a book where some sentences are missing. It's hard to grasp the full story without those pieces. Building on that, cultural nuances add another layer of complexity, much like understanding the backstory behind regional dishes. Topic: Contextual understanding. This helps translators not only swap words but convey emotions and intentions as well. Imagine you have a magic book that translates words from one language to another. This is what the translator service does with text. It offers multilingual translations via a REST API, allowing for easy integration into various applications. Let's explore its features. It detects languages, performs one-to-many translations, and even transcribes scripts. For instance, translating hello in English or detecting bonjour as French. Additionally, phrases like can be transliterated to Roman script, making them accessible globally. Detection, translation, and transliteration are essential processes in multilingual communication. Let's start with detection. The system identified Japanese, ISO code, JO, as the language of topic detection. Moving on to translation, the text is translated into English, hello, and French, bonjour, using ISO codes for precision, topic translation. Lastly, transliteration takes place where we convert from its native Japanese script, Japan, to Latin characters, Latin, resulting in konnichiwa. This enables pronunciation without altering the meaning, topic transliteration. In the realm of translation, various options cater to different needs. Think of word alignment as a map that shows how words from one language connect with another, much like connecting puzzle pieces across languages. Topic: Word alignment. Next, sentence length adjustments ensure your translated sentences maintain their original intent and flow. Imagine resizing images without losing quality. Now let's explore profanity filtering, akin to using a sieve to keep unwanted elements out of your text. These tools help refine translations into clear and appropriate versions. Imagine building a bridge that perfectly fits two distinct lands. Similarly, creating a custom translation model tailors language translation precisely to your needs. Start by accessing the custom translator portal and linking it to your translator resource. Think of it as setting up your construction site. Next, initiate a project where you upload training data files, akin to laying down the foundational stones for your bridge. With this in place, train your model. This is like testing the strength and flexibility of that bridge. Finally, call upon your model via the Translator API by specifying a category parameter with your project category ID, ensuring smooth communication between those two lands. When working in a multilingual lab setting, detecting and translating text is essential for effective communication. Imagine your computer as a polyglot interpreter, effortlessly identifying languages and converting them into your native tongue. This capability allows seamless collaboration across diverse linguistic backgrounds. To effectively monitor comments on your company's website, think of using technology as a detective. You could employ the translator service to catch any profanities lurking in the comments. Now let's explore sentiment analysis with the language service. It helps gauge whether customers are thrilled or disgruntled. Additionally, this tool can pinpoint specific named entities within those comments. Building on that, if you're curious about words like Paris, how do we know if it's a city or a character from the Iliad? We use linked entity extraction with the language service to uncover its context. Lastly, when converting Russian text such as to Latin characters, the translator service's translation function is your go-to tool. Imagine
All right. So as you can see here from our instructor Ali, that present this for us, we're gonna now go over the question. How should you create an application that monitors the comment of your company's website and flags if any indication that customers are unhappy? Well, this is pretty easy as you went over the PowerPoint. It's virtually you all you have to do is check sentiment analysis. This is where it checks whether the customers are happy, satisfied, whether they're disgruntled. You can see that with sentiment analysis, and it will detect. You can use language service to perform sentiment analysis of the comment. The next question we have is: you have text. You have analyzed a text that contains the word Paris. How might you determine if this word refers to the French city or a character in Homer's or in a book? So in this case, what you do is you're gonna go ahead and actually use linked entities to determine whether this is a place or a word in a book somewhere. And the last question is: what function of the translator service should you use to convert the word Russian in a Cyrillic character to that word, which I can again mess up in here in Latin characters? You can use translation. Translation is basically where it allows you to translate the word into, you know, without changing the meaning of the word. So this is again all discussed in the PowerPoint. Hopefully you guys understood this. Now we're gonna move on to the next module. All right, in here in module section 4, we're gonna look at building speech enabled application. This is very important and we're gonna need to do this properly. So without further ado, I'm going to hand over to our presenter for today, Ali, and he's gonna go over this for us. And without further ado, I'll be back when Ali's finished presenting. Ali, you have the floor now.
Welcome to I Teach Skills. I'm your instructor Ali. Welcome to Building Speech-Enabled Applications. Today, we'll explore how these applications bridge the gap between humans and technology through voice. Think of it this way: just as a conductor leads an orchestra without touching an instrument, speech-enabled apps allow you to interact with technology seamlessly using only your voice. Building on that, these applications use natural language processing to understand spoken words and convert them into actions or responses. Imagine having a conversation with your computer where it listens attentively and responds in kind. That's the magic of speech-enabled tech. Let's delve deeper into how this technology works and its practical uses. We'll begin with speech recognition, where computers learn to understand human language much like how you catch the meaning behind a friend's words. Transitioning into synthesis, imagine turning thoughts directly into spoken words. That's what machines do here. Lastly, speech translation bridges languages seamlessly, allowing us to converse across borders as if we're fluent in multiple tongues. Think of speech recognition as teaching a computer to understand human language, much like learning a foreign language. It involves converting spoken words into text or commands that machines can process. Now let's explore speech synthesis, which is the flip side, transforming text back into spoken words, akin to creating an automated storyteller. Dive into the world of Microsoft Speech Service, a powerful suite that enhances human-computer interaction. Think of it like an orchestra where each API plays its part to create harmony in communication. The speech-to-text API captures spoken words and transforms them into text, much like transcribing a conversation. Then there's the text-to-speech API, which turns written content into audible speech. Imagine reading a book out loud but with perfect intonation. Additionally, the speech translation API can bridge language barriers by converting speech from one language to another in real time. Speaker recognition adds an extra layer by identifying who is speaking, akin to recognizing voices at a party. Finally, intent recognition works hand in hand with language understanding to comprehend and act on spoken commands, making it an integral part of creating responsive AI systems. This versatility allows the speech service to operate as both a standalone resource or be integrated into broader cognitive services solutions. Let's delve into the speech-to-text REST APIs, starting with two primary types. The main speech-to-text API is used by the Speech SDK and is preferred for most scenarios due to its robust capabilities. For short audio clips up to 60 seconds, there's a specialized speech-to-text short audio API. Now, let's explore how these are integrated into various programming environments like .NET, Python, and JavaScript through the Speech SDK. The Speech SDK requires setting up resources such as location keys and proxy client objects. Additionally, it uses objects like speech-config and recognizer, which can work with inputs from a microphone or files. A key function within this setup is Recognize Once Async, designed for one-time recognition tasks. This brings us to the properties of the results, including duration and offsetting ticks. Important attributes such as reason, which might indicate recognized speech, no match, or cancelled, and result ID are part of this process. Understanding these elements helps in effectively managing speech-to-text interactions. We are diving into two key REST APIs designed for text-to-speech conversion. The text-to-speech API is generally suitable for most scenarios, whereas the text-to-speech long audio API excels at converting large volumes of text to audio files. Utilizing the Speech SDK in languages like .NET, Python, and JavaScript involves setting up a proxy client object with methods such as speakTextAsync and configuring your speech preferences using speech-config. The output can be directed either to a speaker or saved to a file based on audio config settings. After conversion, you'll find the generated audio in properties like audio data and will receive a reason for the result, indicating success with synthesizing audio complete add or a cancellation. Audio format selection is crucial for tailoring voice output. Think of it as choosing an instrument for a symphony. The right choice creates harmony between technology and human perception. We have options like standard voices, which are synthetic but reliable, like a classic piano, and neural voices that sound incredibly natural, akin to a live singer's performance. The audio file type, sample rate, and bit depth are additional layers of this orchestration, ensuring clarity and quality in the final output. Speech Synthesis Markup Language, or SSML, is an XML-based language that lets you fine-tune how text-to-speech sounds. Think of it like a director for your computer's voice. It can change speaking styles, though only neural voices allow this, to make speech sound cheerful or serious. It also controls prosody, which means adjusting the pitch and speed to mimic natural conversation pauses and even insert background audio. Now let's explore how SSML handles specific elements, say as tags for formatting numbers or dates, phoneme tags for precise pronunciation like saying tomato, and integrating recorded speech. In our code snippet, speak version equals 1.0, we see examples of using neural voices with attributes like cheerful to express emotions in text-to-speech conversion. Let's explore the fascinating world of speech technology, starting with how computers recognize our spoken words. Think of it like teaching a robot to understand human language by recognizing patterns in sound waves. Now let's shift gears to synthesis. This is where computers turn digital text into natural-sounding speech. Imagine a virtual assistant that can speak as smoothly and clearly as a person. Think of speech translation as a bridge between languages. Just like a tour guide helps you navigate unfamiliar territory, this technology interprets spoken words from one language into another almost instantly. Imagine speaking in English and having someone else hear your conversation in Spanish. Speech translation makes that possible. Translation builds on speech recognition by first recognizing and transcribing spoken input. Think of it as translating one language into another, where the original speech is captured in a specific speech recognition language before being converted into one or more target languages. Key components include resource location, key settings, and managing the duration of recognized speech using tools like Translation Recognizer, which offers properties such as duration, offset in ticks, reason, result ID, text, and translations. These elements help to provide reasons for results, like recognized speech or no match, and even handle cancellations. When synthesizing translations into speech, think of it as crafting a unique voice narrative for your translated text. For direct 1:1 translations, you specify the desired voice using translation config and retrieve the audio stream via synthesizing event. Imagine writing an email with a custom signature. It's similar here. The result.getAudio method captures your translation's audio signature. Moving to manual synthesis, which is like translating a novel into multiple languages, you first convert each translated text into speech using a text-to-speech API. Imagine you're at a bustling international conference where languages fly like birds. Our goal is to create a bridge between them using speech translation in our lab. We start by taking someone's spoken words and translating those into another language, essentially transforming one set of sounds into an entirely new set that carries the same meaning. Let's explore how we manage audio processing for transcription in Azure Speech Services. For transcribing audio files into text, you should use the audio config object, topic, speech input. Now let's discuss altering voice characteristics during speech synthesis. You can change the voice by setting the speech synthesis voice name property of the speech config object to your preferred voice name, topic, voice change. Finally, when it comes to translating spoken language and synthesizing translations, you can use the synthesizing event for both single or multiple target languages, topic, translation synthesis.
All right, thank you, our presenter Ali, for going over this. Now that we have this finished, let's go over the module review. So overall, this was very informative and hopefully you guys enjoyed it. Now that we are finished with this, I want to go overhead and just to go over the module review questions with us. So it's basically saying here, which object should you use to specify with the speech input to be transcribed to text as an audio file? So in this case, you got speech config, audio config, speech recognizer. So you're gonna need to use audio config for that. Speech recognizer is used for something else, and audio config is used for audio. Speech recognizer is used for something else. So all of this are not the same. Audio config is your method for sort of resolving this thing. And then he says here, how can you change the voice used in a speech synthesis? In this case, you can use SSML, speech, language, programming language, to set the speech synthesis voice name property of the speech config object to the desired voice name. The other two are not correct because they do not allow for you to use the property correctly. When translating speech, in which cases can you use speech synthesizing event? Let me move this away. This is becoming in the way. Trying to make sure that you guys can see the whole question. It's currently in the way. It's a pain to move around this thing. All right. When translating speech, in which cases can you use the synthesizing event to synthesize the translation and speech? In this case, it says here only when translating to a single target language. You can do it for multiple language because it's gonna trick this tool. Eventually, in the future, that may be available. Right now, it's not. So yeah, that's the end of the presentation. Hopefully, you guys enjoy this and help you prepare for the Microsoft AI 102 AI engineering exam. This is very important exam for those who are trying to learn everything about AI and also become AI engineer. So until next session, I let you go. And this is thanks to I Teach Skills and in partnership with our instructor Ali. We will continue to bring you more. Please subscribe if you haven't already. Hit the like button. And until next time, you have a good rest of the day. Peace.